Okay, so I asked you to fix these. Now, there's a couple things about this, because we're using a walrus operator, it's kind of clunky. The person's going to be entering numbers, but you're really doing it with an input statement. And input, again, always changes everything to text, to string. So they fix it in the next line by coercing it into an integer, but you ought to do that all at once, really. But because you have to allow the possibility of them entering end, which is a string, in this program, it has to be done this way. If you put integer here, when they enter end, you'll have a problem. Okay, so what did I ask you to do? Well, let's go back and just look at some of the output, right? So this one, okay, so the very first one, you're supposed to fix that error. Well, how can you fix that error where it divides by 0? Well, there's several ways to do it, but the way I did it was put it within an if statement. Let's put these side by side so you can compare them. Right, so here's the original one on the left. And this is where if you don't have any test scores, the counter is 0. So when you try to do this division, you can't, because the counter, you can't divide by 0. But you can fix that by just putting it in an if statement and say, if the counter is not 0, then do the same calculation. Okay, and also I did ask that you round everything to real numbers, to 2 decimal places. Okay, and so that's an easy fix too. Here's the first argument to round, which is this division, and here's the second argument, which means two decimal places. Okay, so this fixes that problem. So if you run it and counter is 0, enter my name. Okay, that's real easy, right? So you already did this last week. If you enter stop, right? You enter stop, and so the counter is 0, but because of that if statement, it doesn't blow up. And if I say, yeah, I want to do another one, and I enter stop again, it still won't blow up. Okay, and so that takes care of that. Now, what else? Okay, so Paul Ryan, I think he used to be a weatherman, if I'm not mistaken. No, that was some other Ryan. Okay, you have to do some data validation, which was in the original program anyhow. It has to accept real numbers, but if the person enters a nonsensical score that's not through 0, in the range from 0 to 100, it should tell them, right? So they enter 110. Now, the original program did this anyhow. Okay, so you didn't even have to build this in, but you had to fix it so that it would accept real numbers. Well, how do you do that? Well, that's pretty simple. You just simply you change test score. This is the same code over here, right? Except instead of end being the not the end word, you just change that to stop. That's real easy. But instead of making it an integer, you just make it a float, and you round it to do 2 decimal places like this. It's always better to nest simple functions like this. I mean, you could do it one line after another if you wanted to, have them enter the float and then round it in the next line. But why do that?
For the counter argument, if the counter is not 0, then you get that. Why didn't you have to do if the counter is 0, return 0? Like, why didn't you have to do the second part of that? You just had to say, if the counter is not 0, return this and nothing else.
Well, let me think about that. If the counter is 0, you could have done it that way.
Yeah, that's what I did.
Yeah. Did it work?
Yeah.
Yeah.
It worked just fine. But I'm curious why you didn't have to do that here. You just have to say if it's not zero, it returns this, and then
If it's not zero, it skips this altogether. No, I'm sorry. If it is zero, it skips this altogether. These knots always mess me up. If it is zero, this is false, right?
Yep.
So yeah, so but
so
you
it
could do it.
skips that.
Yeah, but yeah,
So
you could say if it is zero, and then what did you do?
I just said if counter is zero, then return average score of zero. Else, average score is what you have here.
There's many, I won't say infinite, but there are lots of different ways you could write this. But the logic that you just described sounds good to me. And if it works, it works.
So it just returns zero if nothing is there. Like you didn't tell the program that counter equals zero, returns something else, so it doesn't have to it knows to return zero, or it will return zero automatically. It won't return like a blank. Is that how Python works essentially?
Well, you kind of lost me on the blank there, but sure. The if is meant to control execution. So setting average score to zero, if it is zero, that makes sense to me. I can't see your entire program, but a couple other things you had to do here, of course, let's run it one more time. You had to keep track of not only the valid scores, which is done by the counter in the original program, you had to keep track of the invalid scores as well. Okay, so, right, you have at least two more variables that you have to manipulate in the body of the program. You have to have a counter for the invalid scores. You have to have the average score. And let's see, did this thing have an average? Well, it computed it. Okay. I initialized the average score up here. Evidently, this would have worked. I didn't have to do that up here because they didn't do it over here and it worked. It's a calculated score at this point, but it's just good practice to initialize everything up top, right? In my opinion. Okay, but it has to keep track of the invalid scores, and it does that here, right? So if the user enters a good score between 0 and 100, it ups the counter, and the counter counts the valid ones. Else, it ups the counter for invalid, and it just spits back this message about the test score must be between 0 and 100. Let's just do it one more time. So, right, so enter your name. Yeah, I'll just wing it. Okay, Jeff Ubona. And I'll put in a couple of bogus test scores, and it tells me can't do that. It's got to be between 0 and 100. So I'll do it again anyway. 110. That's not a good score. It's counting those, right? So I enter a few real scores, real both as real numbers and valid. When I say real, I mean they're valid scores. My students aren't very good. There's a 34%. Okay, so do all that, and then we say stop, and it gives us a total score. Again, notice this, right? That's an error, right? If you add all these up, you'll get 178.98. But floating point numbers, because of the way they're stored, give you this rounding anomaly. I can't tell you why, but it does. Average score, this is 2. It should have been 2 as well. I'm not sure why it's not. Number valid, 3, and number of discarded. And if I try to kill it now, the program is still running. So it wants me to enter a no down here. Actually, if you enter anything other than yes, if I enter X, it will also stop, right? Because it's just testing to see whether this is an uppercase Y or lowercase y. That's something that I ask you to fix, I think, in the exercise for today. either today or next week. You want to make these programs, you want to do a couple of things. You want to tell the user what they're supposed to do, and then police it, or if not police it, at least if they don't do that, send them back a nice message without having a runtime error. Nice message saying, no, Jeff, you didn't read, you were supposed to enter such and such. So the program doesn't blow up, so that you don't get those types of errors. Okay. So any more comments or questions? Okay, so let's go over and talk about functions. And again, I know that I tend to ramble on up here, and this is your, this is a workshop really, and it's your workshop. So just speak, if feel free to interrupt me at any time.
Professor?
Yes.
Hi, I have a question. So in the comments, another classmate and I have both been asking, is it possible to get could you post the answers to the exercises so we could compare? And then ideally, it would be possible to get the answers to the exercises a little bit before class, because what I'm doing right now is I'm comparing my answer to what you did. I'm trying to kind of keep up, but since there are different ways of solving the same thing, I thought it might be good if we could kind of compare it and then come to you with questions.
Absolutely. And I apologize for not doing that. Just between you and I do use some of these in my class, and I'm trying to circle the wagons. But yes, I can certainly, I will.
Thank you.
Yeah, you're welcome. I can send .py files through Gmail. I can't send them from my university address because they don't like .py or zip files for that matter. Okay, so that's that. Okay, so some of you I'm sure have quite a bit of programming, and others maybe not so much. Python has similarities to R, and in this way particularly, both are object-oriented, both actually are hybrid. Python is called object-oriented, but it's actually both object-oriented and a functional programming language. Back in the way old days, the 1980s, there weren't any object-oriented programs. They came around in the 90s. Everything was procedural or data-driven. Okay, and the object-oriented approach, which was hailed as a great step forward for programming in the 1990s, gave you classes and inheritance and polymorphism and information hiding and all of these great characteristics of object-oriented languages that made them much easier to, one, build, and two, maintain. But the predominance of functional programming remains to this day, and both R and Python they're hybrid in the sense they're both object-oriented and functional. Well, what does that mean? Well, it means, one, you can develop your own functions, of course. We've been using a lot of Python native functions, all of those things that we just call without defining. Those are all Python native functions, but you can define your own functions using the DEF keyword. And functions, of course, are reusable, right? But not only can you define individual functions, which is very handy, but there are so-called modules. There are Python modules that you can import, and a module is generally just a very short list contains some special functions that is one file. Generally, it's just one file with all these functions in it that you import into your runtime environment, into your session.